Okay, our third video in our trends is all about electron affinity. EA for short. EA Sports. It's on the game. All right, so EA, electron affinity. Affinity means that you really, really love and desire it, like dark chocolate and puppy dogs and expensive shoes and designer handbags or really nice cars. Yeah, you have an affinity for that. Infinity is forever and ever. Okay, so that's not the same thing. So an electron affinity means that there's an energy change that accompanies by adding electrons, forming that negative ion, also referred to as our anions. Okay, some of these elements are going to release energy when making an anion, some will gain. So it totally depends on the substance. All right, but the trend that we see is if we travel down the periodic table, down our group, the electron affinities begin to decrease. Remember, this is where the big radii are. That pull of the nucleus is really not as strong, so how can they attract other electrons? Remember, their ionization energy is really, really low, and they're able to lose electrons, so they will not gain. And I'll let you know right here, noble gases don't have any attraction whatsoever. All right, so they are not going to see any type of addition of electrons whatsoever. Okay, but as we travel across from left to right, just like we read, okay, the electron affinities generally increase. It's easier to add electrons. And again, it goes back to the reason why our atomic radius is smaller to the right. The radius is smaller because of that increased nuclear charge. All right, so that pull of the electron is going, or the pull of the nucleus is going to pull some electrons into that empty space. They're really, really tiny. So when you get this filled valence electron, that filled outer shell, you're going to see all of the negatively charged anions form on the right-hand side. Okay, so again, going back to our atomic radius. So if you take a look at this nice little summary chart right here, you're going to see over here for our uh, noble gases, nothing is listed. Okay, so they are not going to participate whatsoever because they don't form their ions. Okay, and instead we have really nice numbers over here for fluorine. He's actually the most attractive of them all, and we'll talk about that in a little bit as well. Okay, so again, let's draw our trends for ourselves. If you have a piece of paper, or something quick to doodle on, it's a really good idea. All right, because it really helps solidify all this stuff together. All right, so first we have atomic radius, which is half the size, half the distance between um, the two radii of a homonuclear diatomic molecule. The radius is going to increase as we go down. So our biggest element is francium, and our smallest element is going to be helium. So it's going to decrease as we go across. Ionization energy, which is the amount of energy it takes to remove an electron, is going to decrease as we go down. And as we go across, it's going to increase. So that means that the cations are going to form on the left-hand side, and our third trend is going to be electron affinity. Okay, the tendency to attract electrons. So as we travel down, Uncle Frank is all big, not so attractive. Frankenstein's not so attractive. But as you travel across, oh yeah, that's where all the attractive ones are. So anions form over here, which are negatively charged. All right, so what kind of patterns do you see? All right, and we see decrease and decrease for our electrons, and increase for our radius, increase, increase, decrease. So patterns, always looking at patterns here in chemistry. All right, so your turn. Okay, put these elements in order of increasing electron affinity. Okay, so electron affinity as we travel down is going to decrease, and as we travel across is going to increase. All right, so we have our carbon, nitrogen, lithium, fluorine, oxygen. So we are either writing these LiCNOF or FONCLI. So again, let's make sure that we are aware increasing means small to big. So we have to put these in the correct order. So increases to the right, so I write them to the right. Lithium goes first, fluorine goes last. The correct answer is LiCNO. And lastly, F. That is an increasing electron affinity. Stay tuned for ionic radius.